is share your screen, keep your audio going, see the screen.
We okay now?
Yes, all the way. Got
All
screen
right.
and got audio.
Sorry about that. I had to restart Zoom to get it to work. Okay. Let me preface this by saying that um, this is really a reference for newbies coming onto the digital modes in microwave. I'm sure a lot of the folks here have already solved this problem with different methods, but I'll just show a quick way of how I connected my little FT290R to a 10 gigahertz and a 24 gigahertz transverter so I could use digital modes. And for this, I used a signal link for the interface, and it makes it kind of handy. Certainly easier than using a 4-contact audio jack on most of these laptops, if you've ever tried soldering to one of those. Signal link uses a relay for the PTT, which is used as PTT in. What happened here? Which is used as PTT in to the transverter. So there you've got built-in tolerance for the voltages, different voltages in the transverter, which is what the next statement says. It obviates the issues with plus 12, plus 24 PTT transverter relay coils. Uses the TR relay contact in the exverter to provide a PTT out, and then PTT out is recombined into the mic cable going to the IF rig, and that'll be pretty obvious here in the picture when it comes up, or the diagram. The whole objective is to make sure that you ensure the transverter's in TX mode before keying the IF rig. There's a couple times I've blown out the back end of transverters, and doesn't take too long to learn the lesson. Audio output is not available on the FT290R mic connector, so I had to use a separate speaker jack for receive audio, and that goes into the side. That's just a quirk because the 290s are pretty old. There is a spare pin on the mic connector, but I couldn't get to it, so went on and used the separate cable. Okay, here's a block diagram of it. Signal link on the left gets a USB cable from the computer for audio and control, and it drives a breakout box, which is just a little box that you add, and it breaks out the PTT in and goes through the transverter to get PTT out, and then the PTT out is combined to go back to the IF radio. Not much with RF audio here, but it's mainly the PTT that you're trying to break out, get control of. Okay, here's what it looks like connected. Laptop on the left. That's the 10 gigahertz transverter I just built a few months ago. The FT290 is to the right of that. Signal links on top of it. And then this breakout box is just a little 2.5 by 3 inch plastic box. That worked good for that. So basically a few cables and boxes to keep track of, but only 2 more than using the straight signal link to the FT290. Extra mic cable and a stereo jumper cable. If you wanted to use the FT290 on 2 meters, you just plug that cable into the RCA jacks on the side of the breakup box. Need to have the transverter or the PTT in, PTT out jacks sequence. Well, I said that, so you don't transmit before enabling the radio. Okay, that was just a quickie. Like I said, main objective is to put it up for reference for folks trying to get on with it.
Yeah.
Is there any significance to the FT290R, or is that just a radio you had laying
That's the
around?
radio I had.
Okay, very
I
good.
think you can use any radio you've got.
Yeah. Have you tried the DigiRig, the little DigiRig boxes by chance?
No, haven't tried those.
Okay.
Okay.
We do have somebody here that has tried those DigiRig boxes and implemented them, and that's Matt Cuby. But his radio is 25 or 30 years newer than an FT290R. This is a universal problem to overcome, and something that has to be understood. I know Paul, KI5EMN, and we've got probably 3 or 4 of these FT290Rs between us, and we've used them on all the bands, all the way to 122. At 122, you're just using it as a receiver, but using it on the lower microwave bands, like 10 and 24 gigahertz. Paul, I think you still use an FT290 on your 10 and 24 rig.
Yeah, the demonstration I gave some time back with the Signal Link box with the FT290, I think that model is like is it an MK2, Jim? I'm not sure. It's a little different, but it's capable of using just the mic cable, and it transmits. I noticed in Greg's presentation here, he's having to use the RCA out. With the FT290, the model we're using, I was able to use the mic cable, and I built my first mic cable, cannibalizing a mic, but then was able to find the cable online that actually worked directly without any problem. But yeah, we use the FT290 for the 1024 rig for sure.
Yeah, 10 gigahertz and 24 gigahertz. And it gives Keith Borland a fit because we're always 2 kilohertz off frequency.
Amen. Yeah, that's the problem with it.
Yeah.
We get a lot of input for that, for sure.
Yeah, that's a joke.
Take control, Jim.
Okay, thank you, Greg. Appreciate that presentation. Something really important, especially for the folks just getting started. If you go out there, these FT290s are on eBay all the time. Got to be careful. Don't pay $100 for it because that's going to be a broke one. But we've got, like I said, we got 3 or 4 of them laying around here, and they've been good little rigs for us. I was using it 20, 25 years ago for other applications that were digital, but they still work even today. All right, so we're going to move on to Al Ward, who has a presentation on our beacon status. It's really a report. So let me see if I can get that going.
All right, can you hear me, Jim?
5x9.
5x9. Yeah, I too also had an FT290 and used it for a number of years. And they also have FT790s, for 432.
Yeah.
But I never had one of them. All right, well, I'm going to give an update on the beacons because we're actually going to try to get something going here. We've been in kind of a stagnant mode with limited access to the top of the dorm at TWU. So I'm going to start out with the first slide shows status of a little over 2 years ago. And I hate to say it, not much has changed out at TWU. I don't think we've been there in at least 2 years, maybe more. But I just wanted to go down the whole list because there's some beacons that are still off the air, like the 6-meter beacon. And the 2 meter beacon are up in Desert, Texas, which is just up in the northeastern corner of Collin County. 2 meters working fine. It's pretty old. It's an old Hamtronics transmitter. The 6 meter one is also an old Hamtronics, I guess FM strip is what it started life as. And I think some tower monkey must have mangled up our 6 meter antenna. So we just gave up on that. And I had another 6 meter halo donated by Gerald at Texas Towers years ago. And Scott AA5AM and I were going to put it up about 60 feet, I don't know, a couple of years ago. And it was just too windy that particular day. And to be honest with you, I haven't climbed a tower in a number of years, so I'm not too sure I still want to do that. So that's why it's off the air. It just needs an antenna. The 222 beacon, Greg, you want to just say a word about that?
222 beacon is on the air, QRV, and there's occasionally short periods when I'm trying to work something on 222, a station on 222, well, unplug it, but it is 99.9% of the time on the air.
All right. Yeah, when you don't hear the 222 beacon, you better check and see what Greg's working. The 430, well, one of the 432 antennas or beacons has been operated out the National Weather Service in Lubbock. Joe Jurechka, N5PO works out there, and it's been up there for years. It's basically a transceiver and a Yagi pointed towards the DFW area. And I think I saw where somebody down in Austin made note of it just recently. So it's still cranking, but look towards Lubbock for that one. And then the 432 through 10 gigahertz are all out at the TWU dorm. The 432 beacon has been on for quite a while. Greg's done a lot of work on it. It's got a little warbliness to it. And as you go up in frequency, the 902 and the 1296 are operational, but they even have some more warble to them. And I think it's all related to a 10 meg oscillator. And what's really strange is if you listen to the 1296 beacon, it's almost like it's got 3 or 4 states of varying tone, if you will. So it's kind of like Wes was talking about before, kind of varying the 10 meg reference. So I'm going to blame it on the 10 meg reference right now, since they all run off the same 10 meg OCXO. But why on earth it's like that, I have no idea. It's I can't remember the brand, but Wes and I put it up there some years ago, and it was ran off of 24 volts. So maybe it has something to do with the power supply. And let's see, 2304 has died. The 3456 was taken off the air because we no longer had access to that part of the band. And then a new beacon, well, a modified beacon at 3400 was generated, and we're going to try to get that up there. The 5760 still works fine, and the 10 gig still works fine. And see, 24 gig beacon, we've got one here locally up in Greg's area. Did you want to say anything about that particular beacon, Greg?
Yeah, I'm not sure how well it's working at the moment. I tried listening for it a couple of days ago, and I didn't hear it. So it's going to be a few months before I can climb. So maybe I can talk Graham into going up and getting it down, and I can work on it and try to get it going again.
Yeah, it sounds good. Well, the ones that I highlighted here in yellow are the subject of the next slide. Why don't we go over to that one, Jim? I already started talking about some of the work. We're planning a work party on May 23rd, and hopefully we can make that happen. But we have to be escorted because they're afraid that we're going to commit suicide or something off that building. But so I can see, lawsuits must have happened to make something like that take effect. But anyway, we're looking for trying to get authorization for May 23rd. And like I mentioned before, the 432, 902, 1296 beacons, I think they're all perking just fine, except they have the modulation on it. So we're going to swap out the 10 meg OCXO for a new Spectracom receiver and a 10-4 splitter to drive the various beacons. We're also going to use that to drive the 3400 beacon that Greg and I have been working on modifying, and it'll be a 3400.380. And like I said, 5760, 10 gig worked fine. The only thing I can say about the 5 gig is that if you listen to the telemetry, it looks like it's running zero power and not putting anything out. And but I think we've had that problem before. That's probably maybe it's a bad diode or something in the detector. And at some point, I'll publish again how you decode the telemetry. It's just a bunch of numbers being repeated for the different frequencies. Pretty primitive, but it does work. Let's see. And just a reminder, the W5HN beacon or the 10 gig beacon is a DB6NT transverter driving a DEMI, or not transverter, DB6NT beacon assembly driving a DEMI 2.5 watt amplifier. And it's actually been working pretty good. So I'm pretty happy with that. And we also have in the work 24 and 47 gig beacons, mostly the work of Jim, KM5PO. And what was really kind of cool was I was able to copy it at 29 kilometers the last time Jim went out on 47 gigahertz. And Jim, you want to tell us a little bit about the 47 gig beacon, or do you want to do that in another presentation sometime?
I think it would make another presentation because we did some tests at raising and lowering the beacon sector horn. Well, it's all one assembly. I was looking for it here. I can't grab it easily, but it's an assembly that sits on a extendable mast, and you were able to help me understand what the differences were between that assembly at 10 feet versus 20 feet versus 30 feet. So it kind of needs to have its own presentation, but we're working to understand where a beacon like that would make sense to deploy in terms of distance, because you're probably not going to hear it at 100 kilometers, but you might hear it at 45 or 50 kilometers. And that's given that the beacon has no a power amplifier. It's simply a quadrupler that's being driven with an LO that is divided by 4. So that's the way it is working right now. It also has a reference from a GPS. And we should keep exploring the possibility of a PA on this band, or deploy it as it is at somewhere around 40 to 50 kilometers.
Well, for me, TWU is 30 miles. So what is that? 48 kilometers. We used to copy Greg's beacon all the time, or I should say all the time. A lot of the times on 24 gig when it was up there at TWU. And that was one of those TI amplifiers. I think we were running maybe 50 milliwatts on 24 gig. And that was into a slot antenna. And this one, of course, is into a sector horn, which has some gain. I can't remember how much, but it's narrow in the vertical plane and wide in the horizontal plane, which is what you would like for a beacon antenna or something that's got some gain.
Right. So the 47 gig beacon, I think we should just put it up there. And, it has the capability of being turned on and off remotely. So you can turn it on, you can leave it on, you can observe. And we desperately need some understanding of what that frequency behaves like at terrestrial propagation. That will help us, I think, accomplish other things that we're trying to accomplish. The 24 gigahertz is so much easier, and it's not easy, but it's so much easier, and it's considerably easier to generate the power. So there's that.
Oh, very good. Let's see. I skipped over the 2304. Since it apparently died, I'm going to pull it down and not even try to troubleshoot it out there. I think we're going to be on a time crunch anyway with our escort. So my suggestion is we just pull it down and I'll give it a once over. So basically what we're trying to do at this first visit is to clean up the reference on the 432, 902, and 1296, and hopefully with the Spectracom. And that also assumes that the GPS antenna is still connected. I'm going to bring a Leo Bodner unit, which locks real fast, and that'll tell us if we have a GPS antenna that works. Then, if so, we'll install the Spectracom and bring the 2304 home. Things to do in the future, and this has been on our future list for a long time, is a phase lock. No, go back. Don't show that one yet. Future work is to phase lock the 235 and 10 gig, well, 2 and 5 and 10 gig beacons. I shouldn't have put the 3 in there because that's going to happen when the beacon goes in. And also maybe some sort of remote control or remote monitoring of the Spectracom receiver would probably be handy because it's got a bunch of different modes, and you never really know if it's totally locked or not, because as soon as you turn this little puppy on, it's providing 10 megahertz. And it's not the purest 10 megahertz because I think it's still trying to be dithered a little bit, on frequency, even before it's locked on a GPS satellite. So it'd be nice to be able to monitor that guy from a home station. I mean, we've got the books on it, on what's what, and we got Jim, who I'm sure could help us out in that regard. Let's see, install 24 and 47 gig beacons, and I just was thinking today about something I don't want to have to do again, and that's shinny my happy little hiney out on those girders. Why don't you go on to the next slide now? I think we need to, for us old farts, I really don't want to be sliding out there. We used to bring a 3x3 foot piece of plywood and shinny out there and do our work out there. And I think we're sitting about 15 feet above what's below. But I'm not very stable anymore. And I'd like some thought or comment from Wes, if you remember, Wes. Did we just put those out there just to get them away from people, hitting them, or why are they that far out?
Well, the main reason, as you said, was people hitting them, but another was there's some blockage at the height they're at because of the rest of the building, and kind of get them away from that a bit. But the main thing is, when keeping other folks from running into them. One thing that will have that be, we also got to consider is we probably need to raise the heights above those rails to get them over the lip of the building, so that we can easily get the door, so so we can stand on the roof and get, open the door.
Right.
As it is right now, we'd have to turn it, and then we're still back out on those rails.
Are you willing to go out there and fetch the 2304 beacon?
Well, that I was planning on it. Just, not something that I would love to do, but it's something I will do because we got to also install the 34
Yeah.
3 gig at the time.
Well, like I say, it's just something I thought of today, and
Sure.
it's really nice if we can just make it a lot more accessible, and we can actually maybe even sit in a little chair on a high chair or something and work on them.
Yeah. It would be good to, when we do that, some people that are a few years younger than both of us to be
think of
on
a
that
couple.
group.
Alrighty.
I think we're calling on you, Matt.
Yeah, as long as he doesn't have a height problem.
He could probably reach him by just stretching up there. He's like 6'5".
Yeah. Well, you're between 15 and 20 feet to the top of those beams.
Oh.
So above the roof of the above the roof of the main building, the elevator penthouse, the picture was taken standing on it. But that's several feet out to it there.
And I guess just for other people, you might want to clarify this, Wes, but we've got on the beacon box itself, it's the 10 gig beacon antenna to the right, I believe, and then 5 and then 3.
Yeah,
I think the big hunk of PVC is to 2304, correct?
that's correct. And then to the right of that is 902 1296, and on top of that the 432 folded dipole.
Well, that's all I
That's
have.
what is the whip to the left?
That's part of the something DCARA had up there that didn't club. I don't know that it's still there. They've over the years have changed things some.
Yeah, this is really a dated photo. I had to go back and dig. I think it's from well over 10 years ago.
Yeah, these beacons, starting with 902 1296 and then 2304 up through 10, have been there well over 25 years, I believe. So it's amazing how little maintenance over that time we've had to do.
I just a question I had because Mr. Dunbar brought it up, and that's when it took out the 3292 2-meter repeater, the PA, what night was that? Because I heard the beacon Friday night and it wasn't there Saturday morning.
Well, I believe that was before Friday. That I think I've deleted Gerald's email that he put out to the club. I'll touch base with Gerald and ask him. But Al, we had there was a string of bad thunderstorms went through here that I don't think you guys got over the east side of the world there.
Yeah, I think there was. But anyway, that's all I had. We're gonna hopefully get over there and do some work because it's been I don't know, it's been several years and long overdue. So we're hoping this works out. Any questions?
Are these beacons just CW, or how often do they beacon out?
They're on 24/7 when they're active.
Mm-hmm.
Some of them are frequency shift keying. And in fact, if you go back to the first slide, Jim, or not, second one, I guess. Yeah, okay, this one. If you look at the, let's see, did I take that out of here? No, the last column,
Yeah, last column.
it shows on-off keying, so that's regular CW. The ones that are FSK, that's a frequency shift keying, and
Okay.
basically they're a slight dithering of the crystal in the beacon that gives some shift. But I know Jim is, we've been looking at, I think I said RF0 possibly. It'd be nice to have a digital beacon up there and probably on 10 gigahertz. I think that would probably be, enjoyed by a good number of folks.
And then how often do they beacon out? Every minute, every hour,
24/7.
24/7?
There's the pause in between not sending a signal and transmitting ID and any telemetry code and a solid key down is very small, just a few seconds.
Oh, just a few seconds. Okay, so okay, got it.
You should always be able to find it, like I know on 6 meters, a lot of the beacons there's a big pause in there. Well, you don't know if the band
Right.
died or what. But these guys are on continuously, and if you don't want to listen to it, you can just leave your pan adapter on and
See it. Yeah.
see it
I'll
that way.
have to see if I can see it or hear them in St. Paul here. So
Okay, St. Paul, that's out here in the Levant area, right?
yeah, out
Is that
here
where
in
you are?
Wiley. Yeah, Wiley area. Yep,
Okay.
Parker. Yep.
Okay, what's that for a rig?
Well, you should definitely be able to hear the 432 beacon.
Oh, definitely.
Yeah, what have you got for a rig, David?
That's a 9700.
Okay,
32,380.
and the 1296 is pretty loud too. All right, Jim, that's all I got.
Okay, thank you, Al. Are there any other questions or discussions around this?
Guess I'll volunteer myself as tribute to go across those girders. And sorry, it took me a minute to respond to it. I've been in the process of deep cleaning the house, so I'm mainly listening on audio.
Well, we appreciate it. It'd be nice if you could make it there. I think I will bring a piece of plywood because you really do need something to sit on. Those beams are what, I don't know, 6-7 inches wide, and that's it. It doesn't,
I would say no more than 3.
maybe they are. They feel like they're one.
Yeah, something we
Wow.
ought to do. I'll bring a notepad and I'll bring a tape measure, and we can make better measurements of those things for future mountings and so forth.
I will do that. All right, Jim, carry on.
I got one more comment. By the way, the current access to the building is because of some person, I think either threatened or did jump over the side of another building, another TW building a few years back, and they cracked down. And the latest change in things, though, was that we have to be escorted and by a TW employee, and that means 8 to 5 Monday through Friday type thing. That's it.
Well, if you're planning on doing it, that's high enough to make it happen.
Yeah, well, anything over about 20 feet, and you're you can take care of yourself pretty easy.
Just another comment too. We're fortunate that they're still allowing everybody to be up there and going forward. You know, if we just minimize the trips and stuff and keep everything working, it'd be great. But we're fortunate that they're letting us do this, I think.
And that's also another reason for trying to get in and out as quickly as possible. And, you know, really not trying to do any repair work up there unless it's an obvious repair. But, you know, we'll spend our time making sure the Spectracom works on 432, 902, or 903 and 1296. That's probably the most important thing right now. And just to pull one beacon and put another one in there.
Thank you, Al. Other contributors, Wes, thank you. And Matt, we'll sure take you up on it. Al's been trying to arrange this date in such a way where I could get there. And so I told him I'd take off from work. Friday's my best day to do that. And join us, that would really be helpful. You're young, strong, tall, muscular, and there's just no one of us that could match you. Okay, we're going to go into this next presentation. This is about Starlink. Unless you're under a rock somewhere, you know about Starlink and their strategy to deploy to the world internet coverage. Well, in the process of doing this, they have to cover the Earth and these happen to be LEO or low Earth orbit satellites. So we're going to look at this because it so happens that besides what they're trying to accomplish with the internet coverage, they're also leaking some tones, and you can receive these. So, amateur radio operators and satellite signal receiving enthusiasts have been searching for narrowband signals from Starlink for at least 20 years. And there are two significant researchers. They're amateurs, but this first, and these are clickable links here, known as SGC Derek, has some basic information on how to receive the Starlink linkage. And Olev Kotov has a personal blog. Now, this individual is in Kyiv, Ukraine. So he's under a different kind of suffering right now, but he has a blog that starts off showing a link back in 2019 that shows a variety of leakage tones that are being received. On to something more scientific, there was an academic research project done at the University of Texas at Austin. This link is clickable. You can click on this. There is some math involved here, warning. But the abstract is worth reading. It says, we developed a technique for blind signal identification of the Starlink downlink signal in the 10.7 to 12.7. That's 2 gigahertz. And present a detailed picture of the signal structure, Importantly, the signal characterization offered herein includes the exact values of synchronization sequences embedded in the signal that can be exploited to produce cyto range measurements. Such an understanding of the signal is essential to emerging efforts that seek to dual purpose Starlink signals for positioning, navigation, and timing, despite their being designed solely for broadband internet provision. So the system they designed, I would love to have had. It's a 40 dBi K-band parabolic on the left side. It's coming in through an LNB block with conversion gain of 60 dB, noise figure of 0.8 dB. Out of that comes a 1 to 2 gigahertz tunable 5% bandpass filter, a splitter, and then both a wideband capture and a narrowband capture. There is a GPS 10 megs OCXO feeding back in as a ref on the low noise block. We're going to take two different snapshots. One is going to be the wideband capture. And look at this narrowband capture, which is running 62.5 megasamples per second. That's really big. Running into 3 terabyte of rate. So let's look at the spectrum usage. There's a supporting document to this that basically is the FCC grant to Elon Musk and the Starlink frequency usage. And most important is the top bar, which we see the downlink. It runs from 10.7 to 12.7. So 2 gigahertz of downlink data transmissions. Uplink's not really our concern, but there is the uplink data there. Now, tear down the Starlink channel structure. These channels are 200 and basically it says 240 megahertz, but it's really 250. In this illustration, we have channels 1 and 2 vacant. They're really not vacant anymore, but the F sub S is 240 megahertz. There is FG, which is 10 megahertz. And then the next channel. So there are 2 areas of interest here to us. The first is the comb of leakage tones, which occurs right here in F sub G. This is a 10 megahertz separation where this comb of leakage tones occurs. There is also within the single channel what's known as 4F Foxtrot gutter. This also has a leakage tone. So there's 2 different leakage tones present. This 4F, it basically talks to 4 wide channels. F defined over here on the left as 234,375 hertz. So I actually want to read this because this is from the UTA academic study. Each channel's central four carriers are vacant. That's this 4F, leaving a mid-channel gutter. Reserving such a gutter is a common practice in OFDM. That's the modulation process. Otherwise, leakage from a receiver's mixing frequency may corrupt, but in Starlink's case, a transmitter side linkage tone is present in some gutters for some satellites. And then it goes into a number of different differences between which satellites the gutter tones were received. But I want you to really concentrate on this comb. A guard band with a generous bandwidth, if G equals 10 megahertz, separates adjacent channels. Within some guard bands, there appears a comb of 9 leakage tones, universally spaced over a bandwidth of approximately 350 kilohertz. For example, such combs were observed between channels 5 and 6 and so forth and so on. This is what I found interesting, was the comb of leakage tones between channels. Here we can look at this again. There's these values as far as the width of the channel, the 4F gutter, which is not that interesting to me, but this comb of leakage tones, which I was able to observe. Again, we have this description. Now, here is the comb. So this is, once again, referencing the UT Austin study. They broke this down so that they could actually see this comb that's occurring between channels. So to build a simple receiver, nothing like what they did at UTA with a grant, we just get a low-cost LMB. Yellow is 9750. We put a bias T on it, and then we use any SDR receiver. Really, the RTL SDR dongle works great. And then any SDR software. I've got a GNU radio receiver. I got an SDR console, SDR Angel. Anything will work. Look at these specs if you believe them. But these things are like, they're less than $10. It does come with an F connector, so you're going to have to adapt that down to, I guess, MA. And here's my setup. It's very simple. I used a hack RF, but you can use an RTL SDR. This is literally on the back porch on the picnic table. And on the right side, you see the bias T. You see the LNB. It's attached to a vertical support, pointed straight up. I tried to aim this thing. I found some material that led me to believe that the constellation of the satellites was 50 degrees, 50 to 60 degrees above the equator. And then I found other empirical information that said you'll receive it best if you point towards the north. I ended up just pointing straight up, and I had no problem receiving these leakage tones. And so now I'm going to play those. Hope this will play. Let's see if we've got this set in such a way that it will play. This will work. Not sure you're hearing that. These are the leakage tones.
Yes, we hear it, Jim. We heard it.
Thanks, Bob. I screwed up the marker on that one. I'll fix it here.
And then the frequency shift you're seeing is from Doppler shift, right?
Right. Okay, I'm going to pause this a moment. I'm going to come back and look at this. Hopefully you can see this on the left-hand side. This is very much the leakage tones. It looks very similar to what we had here.
What are the significance of these leakage tones? I mean, is there interesting data in them, or is it the fact that you can receive them? What's so interesting about them?
I think what's interesting about them is that they represent a beacon that we can receive. And they are the result of the modulation scheme that Starlink is using. And they recognize that this gutter of 10 megahertz is where the mixing products need to land. So it's like, if you know you're going to take a crap, you better plan for it and provide a space in the spectrum. Sadly, it's 10 megahertz. And what we're receiving is that crap, if you want to call it that, but it is the leakage tones and the comb. And seeing the comb itself confirms that it is between channel leakage. See several tones here. Sure you can hear that, but there are multiple satellite leakages, if you want to call it that. Now I messed up the marker here, but I will get it back on track here in a moment. There it goes. And really, what I wanted to show, let me pause this for a moment and back it up, is to show this comb. There's a comb here. That's proof positive that we are receiving the between channel comb. Looks more like the right half of this, but I can't explain why it's not better than that. So let's talk about how this setup occurred. So here's my sorry, one moment. Some technical difficulty. It wouldn't be right if we didn't have that. Okay. So back to this again. You can see all these streaming streaks, all these streaks across the waterfall. And I will go on to this. So there's been a low frequency study. I wanted to share this because this is the latest. There are some, what you and I were just looking at were gutter frequency leakages, which are up in the 10.7 to 12.7 gigahertz area. This study is about some of the V2 mini Starlink satellites. This is a new generation, V2, that are emitting low frequency, relatively speaking. They're around the FM band, as you and I know it. And I want to play this video. Now, there's no audio to this, but I'm going to stop it and pause it to show you so you can see the Starlink satellites coming up on the right at about 5 o'clock here. Now the sun is notated, and on the left, that's the all sky image. This would be something that Wes could explain to us. But you've got Cygnus A, Cassiopeia A. That's the remnant of a, what do they call it, supernova. And so this is a sky. This is a sky location. And you're going to see these Starlink satellites crawl across this image. Let's play it. And you can see that. Let's play it again. So this LOFAR study has gone on to say that there's a lot of problems with these satellites. There's about possibly 10,000-ish satellites up there right now. There's going to be 1 million by the end of this decade. So these are going to cause problems for astronomy, and they are at different levels. I did not show the FCC permissions, but some of these satellites are at one height, and then quite a few of them are at other heights. So there's all kinds of Doppler effects. See if I can advance the slide. Yeah, I'm just down to the references. So here is everything that you might need to know, and I'm open to comments. Anybody got anything to add to this?
I dropped a link to a map that I found pretty interesting that shows all the Starlink satellites on a globe. It's a link in the chat I put out there. You never realize how many are already up there.
Let me mention that this is not just Starlink, that a lot of other companies are working on this, and
Yeah,
other
Amazon.
countries are also working on this as well.
Amazon's the next big one, right?
Yeah. But on the upside, from our point of view, as long as they're moving through in Doppler shift, they're going to be short-lived in your signal. And they're also, if you're working with a dish and you're more directional, so you're less apt to pick them up potentially. But it could also be a source for you to check your receiver to see if you're hearing something blip through there, like a beacon. Those are just my random thoughts.
Very good. All right. I'll get queued up for the next presentation.
The other thing I was just thinking about, I'm not sure where these things are being made, but if we knew that, there may be a junkyard nearby that there's a good source of parts. That's what we found in the past with some of the, like the Collins surplus and other things that we were finding TI.
All right, guys, I want to talk to you about a beacon exciter that I got a couple of these units Monday, not even a week ago, and got to play with this a little bit. And I think there's potential use for North Texas microwave. And I'd like to show you what I've learned. So, first of all, what is it? Well, it's this board, and it's about $90. I got several of them. There's a bunch of functionality on this board, and you can tell that the designers have faced the same thing that we are facing, and others have faced about how do I drive a beacon. And I already had a plan as to how I was going to modulate a CW beacon at 24 gigahertz and also 47, but we've already got the 47 done. So here's how it lays out. There is a central microcomputer processor. It's called M0 Plus. So this is probably not new knowledge for some of you, but it's basically going to have Arduino capability to have 28 I/O pins. That's in the center of this topology. To the left, it has USB that is ESD protected, so we can program the thing either locally or remote. To the right, it's got 16 kilobyte of EEPROM. Mine came shipped with that. There is a socket, but there's an SMD 16 kilobyte chip on the board. Going from the upper left to the right, it's got a GPS on it, Neo 7. We're real familiar with that. It's got a driver, so this is socket loaded ULN 2803A, which is 8 Darlington pairs. We'll talk about that. Nice way to flip relays, Paul Sarver. RF side, it's got an SI5351A, got a couple of outputs. This chip basically goes to about 300 megahertz. That's not microwave, but it has harmonics that are usable. It's got a filter, but you can adjust this. Down on the bottom, it's got shield ready pin out for LCDs and it's got these LEDs. I just spin through this real quick. The GPS DO is a Neo 7M. It's got 1 PPS accuracy. It's got preamp. It's got sensitivity better than minus 147 dBm. Output power is 13 dBm. So it's good, sturdy GPS DO. The RF generator runs from 2 kilohertz up to 300 megahertz, plus the harmonics. Harmonics usable beyond 1 gig. The output is balanced, split, or combined. Frequency res is 1 hertz. Output power is 13 dBm above 1 megahertz. You have some attenuator control. It has a separate power supply. Now, talk about the processor. So it is a Cortex ARM M0 microchip by this number. And just to compare it across from Arduino to Uno, that should say Nano, it says Namo, should say Nano. So it's clocked pretty high at 48 megahertz. The clock type is 10 parts per million. The architecture is 32 bits, same as the Arduino Zero. Program memory, 256 kilobytes, same as the Arduino. EEPROM, 16 kilobytes. You won't have it with the Arduino Zero. SRAM is 32 kilobytes. ADC is 12 bits. DAC is 10 bits. And the I/O ports free are 28. So this is a big boost for us, potentially. Right, so there's these this in-chip, in-socket ULN 2803. It's a Darlington pair. And when the COM pin up here with the diode is tied to the coil supply voltage, the chip is able to drive inductive lobes to suppress the kickback voltage. And then there's a drawing down here as to how you would hook this up. This is Paul Sarver territory. So, all of these digital inputs are just, you flip those through the Arduino sketch and you set these outputs driven by this VSUP on the bottom. So you can have 8 relays. Here's a clip out of their PowerPoint presentation. So you start up here in the upper left with the GPS coming in, and you get this is the IC that's in the socket that does the inductive power changes. RF is generated over here, which you can shield on this gold trace. You can also get two-tone or I and Q. You see the EEPROM in the middle. And then on the bottom, there are several LEDs. There'll be a demo I'm going to show you. There's a green, in my case, there's a green LED that lights to indicate that GPS is active and solid. There's a middle LED that clicks on each second from the GPS. And then there is a far left LED that indicates that the card is outputting RF. There's a USB connector down here in the lower left. This is ESD protected. And not insignificantly is a PCB shield that can be placed on top here, which I will probably do. There's a GPS USB socket. There's also a backup. You can use either a battery backup or a super cap. So that's that. Now, here's where I want to get your attention. Because for frequencies that are way down low, up to about 300 megahertz, or the harmonic, can generate all of these mixed mode beacon. So I'm real interested in this one that says Q65 plus CW plus carrier.
Hey,
These, yes.
Just out of curiosity, can you remotely change which of these is being used?
Yes.
Okay, thank you.
Wes, I think you would have to know the possible selections that you want. And then you would put those in a list, and then you would configure the cell phone app to select that item.
Okay. Thank you.
Yeah. So I thought this was cute. They put RTTY plus CW plus carry, but you can generate whisper. You can generate FT8. Just a regular plain CW plus a carrier. Now, the bottom line here talks about frequency compensation for multipliers up to 72 gigahertz. I'm not so sure about that. I'm going to need a little convincing, but I will get that. So, how do you configure this thing?
Hey, Jim.
Yes.
Yeah, question. Do they mean frequency compensation for multipliers? Okay. So that means they can dither the spacing. Is that what they're saying here?
That's what they're saying.
Yeah. Okay. Wow, that's a lot of multiplication.
I'm going to go into that, but I think I want to test that before I mislead anybody. But hang on, couple slides. So how do you configure this thing? You can access pre-written Arduino sketches and install them or modify them. You can also use something called the RF0 Manager, which allows configuration of existing Arduino sketches and downloading them to the board, or use both, which is what I did. Customize whatever you want. Roll your own Arduino code. And here for the beacon, use a mixed mode beacon sketch, configure the sketch for our use, and then modify the sketch to add the other stuff we need related to polling the hologram card, setting DC control relays, etc. This eliminates the need for a separate Arduino. That might not mean something right now, but let me show you what I'm talking about. So the configuration of one, I've got several of these here. The configuration of my test item was to use the RF0 library item, Beacon Q65 plus CW plus carrier. And then in the specific configuration, I said down towards the lower last paragraph, nominal beacon frequency in use in hertz, 144.360.000. And then the CW speed is, it's just relative. And then the call sign for the CW was KM5PO stroke B. The locator for the CW beacon is EM12IL56. And here is MGM. This is the Q65 message. KM5PO space Q65 space BCN. And then the Q65 mode at the last line, there's about a dozen configuration items, and I chose number 6, which is 30B. So this is how I poked all this into my RF0. But here is a breakout of what's called calculate tones multi. I don't know about this. Maybe somebody here does, but basically, if you look down here at the bottom, calculates the register values for the tones for the entire sequence relative to the nominal frequency and taking the multiplier value into account. The tones can be for the CW part, the MGM, which would be the digital part only, carrier with 800 hertz CW modulation, tone offset, MGM tones, or all of them. So look at this last line. Last line. Unsigned integer 8T multiplier. The multiplier value from 1 to 255. So I want to test that. I didn't have time to do that. I just got these on Monday. Here's my test setup. Let's talk about this. This is the RF0 board to the lower left. You'll see 3 LEDs. There's a red light that's going to key on transmit output. During WSJT, it will be half the symbol rate. The yellow light is the 1 second register from the GPS, and the green light is the GPS active and good. This is an ICOM 705 set for the frequency that I programmed into the RF0. You see me holding. I had some trouble trying to figure out how to make this signal as weak as I could. And I've got an attenuator and a 2-watt load and a 50 ohm lobe on the end. I just messed around with combinations until I could get this as weak as possible without disappearing. The black box to the right is just a 5-volt charge your iPhone device, a battery. And on the near my hand, there is a GPS antenna attached. Okay, I'll go play this now. Hope this will come across. Now, you'll have to be patient because it takes a while for us to work through the CW beacon, a carrier, and then a WSJT Q65 30B. Here we go. There'll be no decode there. So we'll get at least 30 seconds of carrier. As we clock over 0, we'll start the WSJT. There's the decode. All right. If you're still with us and we didn't put you to sleep, I
Hard
think
to
you can
sleep in
see
that noise.
what, Kent?
Hard to sleep at that much noise.
Well, okay. I think you get the idea there. Yeah, I was gonna pull this out, but I thought I'd leave it because I've got all this equipment and I could make this happen, but I want to prove some things around the multiplicity. I can't say that word, but how is that multiply factor used that we saw in the documentation. So I think just building, you have to build something that uses a multiple. So the 222 wouldn't do it because 222 is available in the RF0. I've got this equipment. I can put this together, but we don't need another 222 megahertz beacon. So I've got to do some work to figure out how to multiply the output and then use that multiply value, because that's a value that you're right. But here on the 24 gigahertz, I'm really hoping this is going to work. And Kevin Hobbs has made this work. So I just intend to take an XN module, which is different from the XP, and then just drive it with 10 to 13 dBm of 144 megahertz out of the RF0. And hopefully we're going to get 1.5 watts out of the waveland. If that works, then it simplifies this beacon design, because here's kind of where we're at with the beacon 24 and 47. On the left is where it sits today. That's what I expect to have to do. And all you got to do is just look on the right side and you see that the part count goes quite a bit down. And everything's centered around this RF0 in the middle of that plot, because it has the GPS and it has the 10 megahertz ref. So we don't have to have a Leo Bodner GPS ref. And we can just go about our business of driving the Wavelab and referencing the Cooney LO for the 47. So there's a possibility that this would simplify our design. This is the DC to DC control board. This is a custom printed circuit board. I will have to make some modifications to this, but it's going to just sit on the shield over the RF0. There's a lot of other stuff they have available. I started to try to list these out. It's just going to take a lot of time. They got a shield that sits on top. They got all these filters, PCB boards. They've got suggested values that you can get to place, whether you want a band pass, you want a band stop, you want a low, you want a high. And there's a lot of other PCBs available, such as DC regulation, I'm forgetting them now, but there's just a lot of other PCBs available. They're very low cost. And you can always get LNA, not LNA, but gain blocks from Kent. Here is a specific amplifier designed for the RF0. It's a 50 watt amp. This link is clickable. Got to add a heat sink. There's a 50 watt amp. So I want to talk about some of the implementations. This one's up in EchoMic 34, a 2-meter beacon. It transmits FT8 plus CW plus dashes on 144, 257, runs 3.5 watts. Their claim was that it's probably the first FT8 beacon ever.
That's a nice beacon.
0 Golf Delta Papa has a 10 gig unit. The RF0 is generating 216. That's multiplied 48 times. You can see the 6x2x4 going on here with the filters. Here is one from Chip. Chip, are you here? I'm not hearing Chip respond, but Chip, November 6th, Charlie Alpha, has a 2-meter whisper beacon that operates from Hawaii using the call KH6HMEB. The power is 40 watts. It's split between southern Japan and the west coast of the U.S. with 7-element Yagis. This is all driven from an RF0. Here's a reference to the homepage, and that's all I've got. Any questions or discussion?
Jim, this is Al. You know, the beacon band on 6 meters is 060 to 080, and it's CW only. So you can't put one down there in the CW band. But some time ago, we were talking about a beacon band on 6 meters for digital signals. And I don't know if anything has come of that or not, but don't put one of these down below 100 on 6.
Yeah, unless it's CW mode only.
Right.
Hey, Jim,
Did you-
this is Wes. Okay, where's my notebook? The beacon, the AB5 N beacon, it's currently off the air due to some local interference problem with a repeater. And if anybody's got an extra 2-meter cavity that'd like to get out of their garage, it could probably put to be a good use up there.
Does the RF0 have any problems, or is it all just overload?
That I don't know, Al. I probably overload, but who knows?
Well familiar with that.
Looking for a pass band or a notch filter?
Kent, I would say pass band, but I'm just guessing.
What frequency are you trying to get rid of?
It's not get rid of, it's keep him from interfering with a 2-meter repeater. So that's why I say pass band, just pass the passing the just a second. The 144.274.
And what do you know the input of the repeater?
I don't know anything about the repeater.
Okay, I'm just thinking
Scott may have more info on that than I do.
I've got some pretty narrow filters. I was just wondering which way to tune it.
Yeah. Well, maybe you can get together with let me find out the contact information and I'll get back with you.
Hey Jim, a comment on the RF0 using it with the 10 gigahertz NTMS beacon.
Go ahead.
Yeah, that multiply function in the RF0, if you were to set that to 96 and set the RF0 to be 108.0, whatever the current reference is, that should work for the beacon as a test. In other words, what they're doing is de-spreading the tones in the Q65 so that when they get multiplied, they spread back out to what they should be. That makes sense. In other words, if you're using the RF0 to drive a times 96 brick, phase lock multiplier. That's what they were targeting that function for.
Yes. Got it, Charlie. That's something I want to test. My only question on this was whether their ability to write a multiplier value into the chip applied to a specific modulation, or if it would also work for Q65. In Europe, I'm going to talk about Europe, they've got a different protocol, a digital protocol that they use there that they're very keen to use, and it's not our WSJT.
Yeah, there's
so I didn't know if I didn't know if they made that multiplicity feature unique to that mode, or if it also applied to Q65, because in my mind, I'm having trouble figuring out how we could squeeze down the tone spacing on Q65 times 96 or whatever it is, 92.
What mode you talking about in Europe?
Can you shed some light on that, Dave?
Well, what mode are you talking about in Europe that they use over here?
Is it the Pi 4?
It's Pi 4. It's Pi 4.
Oh yeah, that's the one of those Z2M that's been around for quite a few years now. Because WSJT won't decode that, I seem to remember. You have to use a different decoder for it. But you have to be careful if you're Andy G4JNT has come up with some of these synthesizer boards off AliExpress. When you're multiplying up by a huge number, you don't have the resolution on the synthesizer to actually get, to get the step sizes down at baseband. Which is why the modes with the narrower spacings are not so popular over here. Yes, okay, they may be, give you a dB signal capture advantage, but you just can't get the step sizes to produce these small tones.
And I think the RF0 will do sub-hertz programming. I think that question came up on their chat list. So it will do, some narrower sub-hertz type settings.
All right, good to know. I will be testing it. I know that Kevin, VE3KH, has used this board at 24 gigahertz, and I was really interested in doing that. But if we could build, just think if we could build a 10 gig and a 24 gigahertz beacon that transmitted Q65, that's going to increase the value and functionality of those kind of beacons, because we've got folks that don't use CW. And even those of us that do use CW, if we can decode a Q65 signal in digital, it tells us something. We get the signal to noise ratio, and we get something out of that tells us where the propagation is at. And I have to say that we're still in this mode of trying to understand propagation.
And it lets you hear the beacon 10 or 15 dB further away.
That's right.
I think that the issue at the GPS, the Neo 7 chip, does some dithering, and that's why you're not getting the stability that you need to do the higher level of multiplication. And there is another Neo chip that will give you the stability, but it's quite a bit more expensive. So if if we really wanted to do it, I guess we could redesign that section of the thing and get more stability. The 5351A helps with that some, but I think that the Neo chip is a key.
Yes, I've had to play with the Neo trips in the VE2ZAZ GPSDO, and yes, it's the look of the draw whether your Neo 7M is a real Neo 7M, and same with the Neo 8s. But
Right.
I found in one of my cardboard boxes in the loft one of the old Pack Rats Excel site lot boards. They did a Arduino, I think, to drive it many years ago. And I dug that out, and earlier on I was setting up a personal beacon on 24 gigs for tomorrow contest, and it sounds very nice on 47 gigs. You can get quite close into it, and it's very stable. But the old N1JEZ, I think it was. I use that as the reference. It's very simple and very cheap, but it does the dividing down and does the comparison and locking with 100 kilohertz signal. And surprise, surprise, there was 100 kilohertz carriers all up and down 24 gigs, which was quite a surprise. One thing that they have been doing over here is it G4EML has done some code for, it's like a mini Raspberry Pi. It's only about inch by 2 inches. That actually you drive some of these, the AD4351, the Max synthesizer, and the one that you can get on AliExpress, which actually goes to 18 gigs now, I think. He's actually got code that you can put on that, which will run CW and JT4G on a board that's inch by 2 inches. And of course, the Chinese references you can feed an external references in. Admittedly, it's normally has to be 100 megs, which is why Kent had to smuggle in 100 meg multipliers the other week. It sounds very nice on those bands on both 24 and 47 gig. Just some thoughts on some beacon sources.
Hey, Dave, can you drop that in the chat? Some link to that?
It's Kent. Do you get Scatterpoint?
I'm a founding member of the UK microwave group.
Well, there we are then. So you've seen the write-ups, haven't you?
And it was the 73-watt amplifiers for 10 gigahertz. It really made the tariff laws a little weird.
So yeah, I'll tell you which issue is, Kent, and perhaps you can scan it and distribute over here because I don't have a scanner at home.
I have it in PDF.
Well, yeah, there we are then. I think it was, I'll go and look, but I think it was November last year, because he did one where it's just the small Pi board that you just plug into the synth board and off it goes and plays beacons. But then he also did one with a display where you can actually dial up the frequencies and turn it into a beacon.
And this is a possible NTMS project. Mini Circuits is now selling a 3-watt amplifier for 10 gigahertz and a secondary part, which is 3 watts from 10 megahertz to 10 gigahertz and everything in between. One of the chaps in Belgium has done a board for it. I had 50 of the boards made up, purchased 60 of the chips and took those to the UK so guys can build 3-watt amplifiers. The chip cannot be installed by a human. It has to be machine installed. I'm meeting sometime in the near future with a PCB assembler here in Grand Prairie to see if they can at least put the chip down and how much they would charge to go ahead and put the other parts on. So I don't know how many guys are running less than 3 watts, but we could do an NTMS project of making up 3-watt amplifiers.
Going back to the earlier discussion about 122 gigs, I did send out to the NTMS Reflector the 2 PDFs of part 1 and part 2 of the presentation on how to wobble your 10 megs to get digimodes at 122 gigs. You should have seen that by now.
I want
Dave,
amplitude.
I saw it, Dave. It's Wes.
Okay, you did go out then. Good. That's what I wanted to check.
You guys, for this discussion, want to go on nothing much here other than we're in a spring sprint information down here. June. Seventh is our microwave activity day.
Audio breaking up.
Are you hearing me?
I hear you now.
Okay. On the 14th, we have the next Zoom meeting. Please send your presentations. Here are the routine items. We have a 2-meter net every Sunday at 8 p.m. 144.260, called by Ross, Kilo 5 Zulu, Sugar, Juliet. A 6-meter net is called the Hoot Owl net. It's every Saturday, so that's tonight, midnight. 50.125, right on the call frequency. Call by Al, Whiskey 5, Romeo, Lima Golf. There is the NTMS lunch every Tuesday at 11:30. Texas Smokehouse Barbecue, Richardson, Texas. There is a 144 megahertz activity night every Monday from 7 to 11 p.m. local. 222 megahertz activity night. Please get on if you have 222. Every Tuesday, 7 to 11 p.m. local. I'm going to try to make that one next week. 432 every Wednesday from 7 to 11 p.m. local. West Mad, NTMS Mad, first Saturday of every month. I got to go through this. The Zoom meeting cost us $160 a year. Website, Bluehost, $86. A lot of people check out our technical resources. The ARRL liability insurance is $200 a year. The PO box is $146 a year. Our 501c3 profit filing with Texas is $25 a year. this equivocates to an evaluation of $617 divided by $20 of dues requires 31 members. Does not include the meeting room space, which has been zero for a while, but in ARLL, the Spectrum Defense Fund donations, we usually donate. Please support the NTMS with your $20 annual dues.
Currently, guys, we have 19 paid up members for 2025. This is west of A5TKU.
I just joined.
Who was that?
David, KG5EIU.
Oh, yes. Yes.
Okay, if there's no other business, I look for a motion to adjourn.
I
So
make a
move.
motion, we adjourn.
Okay. I'll second.
Third.
Ken, the issue to look at is September 24 for those synthesizer articles of Scatterpoint. I just checked it.
Hey, Wes, can I give you a call on telephone?
Yeah, please do.
All right.
Bye.
So I got a real quick question for anybody that's left. What anybody run the 905 from ICOM? And if you were just starting out, would that be something to look at? Or no good?
I think there's several people that are using that rig. I worked a couple of them up in Oklahoma on
Right.
10 gigahertz.
Right.
We've been trying to work with some locals on 10 gig, but it only puts out a half a watt.
Yeah.
And even though back in the old days we used to work 200 milliwatt DB6NT transverters at a couple hundred miles, a half a watt is it'd be nice if it was a few watts,
Yeah.
But I think if I didn't have a rig right now and I could afford it, I'd probably buy one. But I got too much homebrew stuff and it doesn't gain me anything. But
I mean, it sounds like you still have to add an amp to it or something, right?
yeah, I mean, there was a Dubus article on adding a preamp / amplifier, and it made it up to 8-watt level. But basically, you get Dubus.
I don't know. I like I said, I'm super green here, so I don't.
Okay, I would say look it up, and there's 4 issues a year, and I think it's, I don't know, 40 some odd dollars or something. I can't remember. And we go through a gal up in Alaska, KL7UW's XYL. She's the North American focal point, but you'll find that if you just Google Dubus, and maybe you can get a back copy of it or a PDF. I guess you're not on the NTMS Slack page?
On the Slack page? No, I haven't joined that yet.
How about if I send you a invite
Be great.
and can you pass along your email here?
Yeah, sure. I'll it's KG5EIU at W5FC.org.
All right, I'm writing your call down. KG5EIU at
W5FC.org.
as in Fox Charlie.
Yep, Whiskey 5, Fox Charlie.
Okay. All right. I'll get you an invite for that.
Thank you, Al.
And you're also on the NTMS reflector?
Reflector?
Yeah. I mean, like we have a groups.io.
Oh yeah. Yeah, I just joined that a couple days ago. Yeah. Mm-hmm.
Okay. There's a lot more general stuff kind of going on there, but I think a lot of guys just hang out on Slack and the general page there
Okay.
and just put something out there because there's a couple of guys in Oklahoma that get on that have that rig and a couple of guys down here as well. But I would say if you can afford it, go ahead. It's unless you really want to, try building a lot of stuff. If you don't have the time for it, the 905 would be a good start.
Thank you for the info on that. Yeah, I need to decide, and like you said, my concern is that it's only a half a watt. So whatever you get, you're going to have to add a little bit more to it. And if you're going to add a little bit more to it, then just add a little bit more and just use like a 705.
Yeah.
Yeah, don't let the half watt stop you. I've been running a half watt for what 6-7 years now, and doing pretty good with it.
Yeah.
Okay.